And I'm going to bring that up to meet my line. And I'm going to say that that's about 5 degrees. So it's about, that angle is about 5 degrees. So that's 5 degrees what of what? North of west. Good. That's fine. That's fine. That's the kind of mistake that you'll make a couple times before you get used to them. So that's 5 degrees north of west, because we started at the west and went north. So this is 7.9 meters at 5 degrees north of west. What a crazy little dog. So let's look at what the book has for an answer on that. Wow! Okay, so here's the thing with graphical vector analysis. You're not going to get a precise answer. You can construct it 3 times. Well, I should say this. Your level of precision in your answer is entirely down to your amount of care and sort of anal retentiveness about making your angles very carefully, making your lines very carefully, using your scale very carefully. If you get sloppy, your precision is wildly, well, you just lose precision, period. And you can make the same vector 3 times and get 3 different, very widely spaced answers. So what the book says is that that's 7.9 meters at 4.3 degrees north of west. So that's not too bad. You go ahead and measure yours and see what you got. You got 4 degrees? Okay. So 7.9.
I got
7.9 at 4?
7.9 at 4.
Okay, good. Basically, if you're anywhere between about 7.85 and 7.95, consider that very good precision. If you're anywhere between 4 and 6 degrees, well, maybe 3.5 and what do they say? Maybe between 4 and 5 degrees or a little below 4, you're doing pretty well, especially for a first vector construction. Do I need to reconstruct this so that you get the idea of how to do scales better? Let's do one more example like this. I'm going to erase this one. And sometimes, yeah, if your paper shifts or your ruler shifts when you're drawing, that makes a huge difference. The other thing to think about is, especially if you have some very long vectors, 1 or 2 degrees of difference over a long trajectory gives you significant error. 2 degrees off when your line is...
Shifted off on my 15.
Yeah. You can get a really wild answer that way. Okay, so you can write this down. I'll write it down. I'm making this one up as I go. We have an airplane taking off from a runway. It travels along the ground with a velocity of I'm pulling these numbers out of my head. I don't know if they even are things that would get an airplane off the ground, so forgive me that the numbers are completely unrelated to reality. 230 meters per second along the runway, then takes off with a velocity of 270 meters per second at 24 degrees above the horizon. What is its resultant velocity? And we sometimes show resultant velocity as v sub r. Okay. So, where do you start drawing this one? What do you start with? A little picture of a plane? You can do that. I'm going to switch marker colors here. So, I'm going to get my meter stick, and I've got two numbers I'm working with, 230 and 270. On here, I'll probably do 23 centimeters and 270 centimeters. On your paper, you might do, now if you do 2.3 and 2.7, it's going to be awful tiny. You might want to do 2.3 times 2, 2.7 times 2 to give yourself something that you can work with graphically. The challenge, if your graphical constructions are too tiny, is that it becomes very difficult to read your angles because everything's very clustered together. So you want to give yourself enough space that it's easy to read and not so much space that you're using 3 sheets of paper taped together. Okay? So I'm going to do my 230 and 270. And I'm also using my trick of starting 1 centimeter up from the end of the meter stick, because there's typically it's a mechanical damage issue. You can have a lack of precision due to instrument error. The ends of a lot of these meter sticks are kind of rounded off. They don't really extend that last centimeter. Those rulers, it depends on what condition your ruler's in. Okay, so this is velocity equals 230 meters per second, and we're just going to say that that's positive, it's along the ground. Now comes the weird part. We're going 24 degrees above the horizon. So I'm going to take my protractor, and I'm going to come 24 degrees up from the horizon. So 10, 20, 4. My protractor just shifted. Okay. So I've got my mark to go with. Tell you what, Kelly, can you pass that protractor down so that they have it? And I'm going to go 270. When you're doing vectors that are off at angles other than 90, it's a really good idea to show your angle there. That's a visual reminder for you, and it also clarifies it if somebody else is looking at your construction. Okay. So we can't really say positive, negative. It's just 24 above the horizon. Okay. Let's do our resultant now, and I'm going to switch colors. And remember, your resultant connects what two things? Beginning of your first vector, end of your last vector. So here, I'm going to draw in my resultant. Okay, so this is my resultant, and for a magnitude of my resultant, I get 490 meters per second. Now here's the part I want you to be really careful about. That's the magnitude of the resultant. That part's pretty easy. What's the direction of the resultant? Could I borrow your protractor, Stephen? Thank you. I'll give it right back. So I'm getting an angle here. I'm going to measure the angle between my initial and my resultant. And I'm getting 10, 15. Does yours look different than mine? Did I do something wrong with my 24? Okay. No, okay, I got it. Okay, I'm getting 15 degrees. 15 degrees what? Because if you just put 15 degrees, that doesn't give you enough information. North to west, east to south, up or down. 15 degrees what? What? Are we dealing with north, south, east, and west here? 15 degrees above the horizon. Okay? If you write north of east here, you will get it wrong. So 15 degrees above horizon. Question. Well, what did we say about graphical construction? It's going to be slightly imprecise. We're going to have differences when I construct a graphical vector analysis than when you do. Yeah, there are going to be some variations. That's what I'm getting. How close are we? How close are you to the 490?
I was 485.
485? Okay. 495. And on these, you know, probably, yeah, if you're within 5 either direction on something like that. So if you're at 485, 495, that's pretty good. How are you doing on the angle? How close are we? 14, 15. A degree or two off is to be expected. I'd say if you're within 1 degree, you're doing well. Now, you know, I'm using mine as kind of the standard. Are my vector constructions perfect? No, but I've had a lot of practice and they're pretty good. So, not perfect, but pretty darn good. So, you will, on your quiz tomorrow, you will have a graphical vector to construct, along with one other kind of problem that you're going to learn tomorrow. Let me, what?